This is section 4.8, and we finish up chapter 4 learning about antiderivatives, and then chapter 5 we will really dive into antiderivatives. So the process of recovering a function from a derivative is called anti-differentiation. So we're just going to be going backwards. So if you have f of x is 2x, and you want to know what was the function that would give you this as a derivative? Well, it's x squared plus some constant. We don't know, that constant could be anything. If you had cosine x, what's going to give you that derivative? Well, that's going to be sine x plus c. And it's visual to see x squared plus 1, x squared minus 8, x squared plus 100. All of those have a derivative of 2x. So you have to put the plus c to take into account that possible constant. So there's quite a few integral rules. You know, we had derivative rules, and now there are integral rules. And the big one, the main and first one, is the power. So the integral of x to the n is let's look at 3x squared. Instead of taking 1 away, we're going to add 1. And then whatever you add, whatever you get up here when you add, you divide by that number. So this is 3x cubed over 3, which would just be x cubed. And think about it, if you had just x cubed and you were going to take the derivative of it, you would get 3x squared. For the 4x to the fourth, we're going to add 1, which makes it 5, and divide by 5. So that would be 4x to the fifth over 5. And that would be the integral of this expression. And here's the other rules. I've put the rule box here for you. Integral of sine of kx. So if there's a number in front of x, sine 3x, sine 4x, it's cosine kx, and you divide by the k. And this says negative 1 over k, but you can just say dividing by that k, and it's negative because it's negative cosine. And then all of these are here. You don't necessarily have to memorize them right now, but start learning them, and you'll be using them in chapter 5. But you'll have this to refer to, and then I've put a box on the problem set as well. So these are just some more examples. Integral of 2x is 2x squared over 2 plus c, so that just becomes x squared. Cosine we've talked about. 1 over x, the integral of 1 over x is ln x plus c, so you have ln x for that piece. The integral of e to the x, e to the kx, is e to the kx over k, so let's see what that looks like here. So we had 2e to the 2x. So you have 2e to the 2x divided by 2. And so that's going to cancel out, and you'll just have e to the 2x. So you have ln x plus e to the 2x plus c. Here's another one. X squared minus 2x plus 5. This piece is x cubed over 3. This piece is negative 2x squared over 2 plus 5x. When you have a constant and you integrate it or get the antiderivative, it just becomes an x because you're going up one level. So this becomes 1/3 x cubed minus x squared plus 5x plus c. All right, let's go work on our problem set. There's quite a few problems, but many of them go pretty quickly. They're pretty easy ones. So number 1, find an antiderivative for the function f of x equals 13x to the 12th when c is 0. So in this one, your answer will not have a plus c because they told you it was 0. So 13x to the 13th over 13. Those things cancel out. Your answer that goes in the box is x to the 13th. We've got 3 things here. Negative 3x to the 4th. Well, to the negative fourth. When you add 1, that becomes negative 3x to the negative 3 over negative 3. Those negative 3's cancel out, and you are left with x to the negative 3 plus c. This one, x to the negative 4, you add 1, you get x to the negative 3 over negative 3. They typically would like you to write that as negative 1/3 x to the negative 3 plus c. This one, x to the negative 4 plus 3x squared plus 4. We'll do each piece. This one we get the negative 1/3 x to the negative 3 plus 3x cubed over 3 plus 4x. These 3's cancel out, and you're left with this as your final answer. And I did put this, it's a little bit different chart, but it is right here on our page, so if we want to refer back to it at any point, we can, at least for this video. So number 3. Number 3, I think, has been omitted from your homework, but let's look at it in case. So 29 over 2 square root of x to the 27th. We're going to rewrite that as 29 over 2 x to the 1/2, changing that radical to x to the 1/2 to the 27th. So power to power, now we've got 29 over 2 x to the 27/2. Since we're adding 1, we're going to add 2/2. So it's 29 over 2 x to the 29/2 over 29/2. Those cancel, and you are left with x to the 29/2. Don't know if one like that's in your homework, but you will have looked at it, so we're okay. The homework may not be exactly like this, but these will get you prepared for what you'll encounter. All right, in this one it tells you c is 0, so none of these will have a plus c. So the integral of 1 over x, that's just the rule, ln x. The integral of 6x is 6 times 1 over x, so that's 6 ln x. Integral of 3 minus 7 over x, so we've got 3x for the 3, and then we have minus 7 ln x. Number 5, find this one, negative 11 sine 11x, so k is 11. And if you look at the rule for the integral of sine, let's go back up here. Sine u is negative cosine u plus c. And that doesn't give you the same, let me go to the rules over here because it shows it a little bit better. So if it's sine kx, you are going to have the 1 over k cosine kx plus c. And there's a negative. The integral is negative cosine. All right, so let's go back here. So we have negative 1 over 11 times a negative 11 cosine of 11x. This becomes a positive 1. Negative 1 over 11 times negative 11, that's a positive 1. So you're just left with cosine x. Number 6, integral of 20x plus 7. First piece is 20x squared over 2. That becomes 10x squared. The 7 becomes 7x, and we have a plus c. It will count it wrong if you don't put the plus c on there, so be careful with that. All right, 7. Here's 8t to the 7th plus t over 8. If you'll rewrite it this way, it'd be easier to do this piece. So we have 8t to the 8th over 8, always adding 1 to this, plus 1/8 t squared over 2. You've got two denominators here, so this can be like t squared over 16, and this is t to the 8th plus c. In this one, we're going to rewrite these in negative exponents so we don't have the fractions. So this is x to the negative 5 minus x to the 5th minus 1/3. When you add 1, you get x to the negative 4th over negative 4 minus x to the 6th over 6 minus 1/3 x. Cleaning it up just a little bit, we have negative 1 over 4 x to the 4th, because that was negative exponent, so I had to go to the bottom. Minus x to the 6th over 6 minus x over 3 plus c. And sometimes that formatting, I mean, it shouldn't count it wrong if you don't write it exactly as that is, but just be aware. All right, x to the negative 1/5, we're going to add 5/5, so that makes that 4/5. And then you divide by 4/5. So when you divide by a fraction, when you want it to be on the same line, remember we're going to invert this and put it here. So it's going to be 5/4 x to the 4/5 plus c. On number 10, we've got 9x times this expression. We don't have a product rule or anything for integration, so we're going to go ahead and multiply this out. We're going to distribute, so that becomes 63x minus 9x to the negative 8 when we do that. Then we can integrate, so that's 63x squared over 2 plus 9x to the negative 7 over negative 7, and that's going to be minus a negative, and that'll end up being plus there, and then plus c. All right, number 11, negative 5 cosine t. Well, that's just negative 5 sine t plus c. Negative 11 secant squared x, and if we go back and look, that's not one we've seen yet. Here's the integral of secant squared. It's tan. So let's go back. So that's just negative 11 tan x plus c. 13, e to the 4x plus 9e to the negative x. That becomes e to the 4x over 4 minus 9e to the negative x. And the reason this became a minus is because it's 9e to the negative x divided by negative 1. And that changes that sign, plus c. Number 14, we're going to rewrite this one as a sum of two fractions. So this is going to be 1/2, there's that piece, plus 1/2 cosine 3t. When you integrate the 1/2, you get 1/2 t. Here you've got 1/2, and then it's going to be sine 3t over 3. So you could just write that as a 1/3 plus c. So now we have 1/2 t plus 1/6 sine 3t plus c. In Math Lab, they typically would like it to look like this. T over 2 for that one, sine 3t over 6 plus c. All right, 15. On this one it says you've got a derivative that's 4x minus 7, so you want to find the integral of that, and you know that y of 2 is 0. So we're going to figure out what our c value is by doing this. So the integral of 4x minus 7 is 4x squared over 2. So that's 2x squared minus 7x plus a c. So they said then that y over 2 is equal to, let's plug in 2 for the x's that we have here. 2 times 2 squared minus 7 times 2 plus c. This becomes 8 minus 14 plus c and negative 6 plus c. And they told us also that y2 was 0, so here we can put 0 and solve for c. Our c ends up being 6. So our final answer will be the 2x squared minus 7x plus 6. That's the specific one given this information. All right, last one, same kind of question. So we have the integral of 3x to the negative 8/9. Well, we're going to add 9/9. That makes it 3x to the 1/9 over 1/9 plus c. And so when we bring this to the top, flip it, it becomes 27x to the 1/9 plus c. They tell us that y of -1 is -7. So we first say, well, y of -1, we're going to plug in -1 here. -1 to any power is going to still be -1. -1 times 27 is -27 plus c. They also said this is equal to -7. So instead of writing y of -1, we're going to put our -7 there. Add 27 to this side, and you get 20 is equal to c. So I've now got this, but I can plug in 20 for my c. This is my final answer. So I think that's going to get you started on integration. Most of those go fairly quickly, and you do have 2 different charts, lecture notes and here, to help you in doing those.